This is the database interaction activity in Python. I have the project open along with the README file. There's quite a bit to get through today. This may take a little bit of time, but let's dive in. So our goal is to implement different ways of interacting with the database in Python. Definitely do some research. If you haven't done that, go ahead and do that now. Research different mechanisms, different APIs for interacting with databases in Python. Do that research. When you're ready, pause the video, come back after the research, and then we'll dive in. There are two families of basically APIs or packages that we can use to interact with databases. The first is an ORM, which stands for Object Relational Mapping, and the other is a command query interface. We're going to do one of each. And now there are several different packages you can use. I'm going to pick two of them. I'm going to pick one for the ORM, one for the command query set, so you can kind of see the difference between them. Each package is going to work potentially substantially different. So keep that in mind as you're looking through your code. If you pick a different package, may look very different. That's okay. If you can get it to work, that's fantastic. In fact, the more packages you learn, the better you're going to learn this stuff moving forward. So we want to first make sure our local environment is working. We've got the project open. We'll run a pip env install. So let me start with env shell and pip env install. I always like to run shell first before I run the install, just to make sure we're in the shell. All right, so we are good there. Now at this point, we should be able to run our test. I can run it on the command line, pip env run py test. And I do get failures, or I can run it through the testing window. You'll need to configure the Python test. We are using py test, so when the selection comes up, just make sure to select py test. And then the folder that contains the tests is the tests folder, so make sure to select that. This will refresh, pop up, and again, I can run it from here. So either way is fine. If you want to use the test runner, or if you want to run it on the terminal command line, either way is totally fine. We do have that running, we do have that working. In order to make sure this is going to work locally, I'm going to need to run the schema file in the database. Now, before you run yours, open up the schema file, and you'll want to change your super secret password for your database instance to whatever you used when you installed it. So yours won't be my password, probably. So make sure you use your password that you used when you installed MySQL on the computer that you're running. So once that's done, we'll go ahead and run this. So we'll say py, wow, brain just had a fry. So we want to run pip env. So we run it in the shell, run py. Yours may be, instead of py, it may be py3 or it may be Python. It depends on what you're running on your computer. Py, database, tab, schema, tab. Tab will autocomplete for you. I'll run this, and it drops the database and recreates it in case it was already there. So now that we've got that done, everything is set up for our local environment. We're ready to start implementing the different ways to get these tests to run. So let me switch now over to the test file. Let's take a look at what we've got. There are two tests here. I've got one for commercial properties and one for residential properties. In each case, we're creating a property, we're saving it, we're retrieving all of them from the database, we're making sure there's exactly one, and we're making sure the street address matches. So just a pretty straightforward test to make sure that we can save a record to the database, we can get them all back out, and we get exactly the one that we saved when we were done. So let's head into the code. This is going to be an app property. So under app, there's the properties py file. Here's our code. Here's where we're going to implement the functionality. So in save and then get all, we'll need to implement for commercial property and then for residential property. For commercial property, I'm going to choose to do an ORM, and I'm going to use SQLAlchemy. Now there are several others, including Django and many others. You're welcome to use a different one. I'm just going to use SQLAlchemy for this one. So with SQLAlchemy, the first thing I'm going to need to make sure I do is install SQLAlchemy. So let's look and see what that looks like. So Python, SQLAlchemy, MySQL. Yeah, get started. That looks like a good query. All right, so here is the command I'm looking for. Now I'm not going to run pip, I'm going to run pip env install, but the rest of this will be exactly the same. So we'll say pip env install SQLAlchemy space MySQL. That'll install both of those packages. And we're good to go. Now from here, you can definitely look at the internet search and make sure that you can see what else is going on. In fact, that's a good thing to do, is see what other code there might be. But there's several things that we're going to need to do here in order to get the SQLAlchemy ORM to run. So the first is we're going to need to declare some basic engines for the ORM. So I'm going to do some imports. We'll say from SQLAlchemy. I want to import quite a few things, not quite all those. We do need create engine. We'll need some of these others later, but not quite yet. So I'll just start with create engine. I'm also going to need, actually, let's start with that. So there's more we're going to need, but I want to try to take it a piece at a time. So what we're going to do is we're going to create an engine. And this is actually going to be, it's going to help me out a little bit. So we'll create engine from MySQL, but not MySQL connector. It'll be py MySQL. The root is the root name. The password is my super secret password. If you have special characters like the @ sign, you'll need to escape those. So this is actually %40 instead of the @ sign. This will be at localhost 3306/real estate. 3306 is the port. This is all, if you're curious where this comes from, this is all from the schema file. So I can see here's the username, here's the password. The 127.0.0.1 is the same as localhost. Those are the same thing. And then 3306. And then here's the database name, real estate. So all of this is from the schema file. There's no magic here. So that'll create our engine. Now that we've got that, I need to create the class that maps the commercial property to the database. So to do that, I'm going to need a couple more things. So I'm going to want, in addition to create engine, we'll need column. I'm also going to pull in, let's look at the schema. So ID column is a char38. This is actually a UUID, so this is pretty common. You'll see this. It's a globally unique identifier. The rest of these are varchars, 100, 50, char2, and varchar 10. So these are all strings. So I'm going to want string and UUID. So I'm going to need those types for mappings. I'm also going to need from SQLAlchemy, alchemy.orm, we're going to also import declarative base and session maker. We'll get to those here in just a moment, how we use those. So there's a few different types. Again, internet search will help you out to figure out what you're looking for. But now that we have this, we're going to need to create a base class. So we'll use declarative base to do that. And then we're going to say base.metadata.bind, create all engine. So this will create all of the different objects from the engine based on what we're deriving from base. So this is just boilerplate code that you have to do as a part of it. Now that we've got that, we can create our class that maps to the database table. So we're going to create a class that maps to commercial property. So I'm going to create a class. Now we're already using commercial property as a class. You can see that right here. So what I'm going to do instead is I'm going to say record. So I'm going to give it a different name so it's not the same exact class name. And then this is going to derive from base. And now from here, it's going to help me out quite a bit. So we do want table name equals commercial property. And now we're going to start adding our columns in. So ID column, UUID, yep, that looks pretty good. That is our primary key, and it's going to say it's a type of UUID. We're going to want string. All right, so it's starting to pick things up, which is fantastic. We'll do city, state, and postal code. So the IntelliSense through Copilot is picking up other information from other files. So it's reading the schema file and pulling everything in. So you'll notice the string varchar 100, varchar 50, it's pulling this 150 from this other file. So it's looking at other files that I have and trying to make intelligent inferrals based on what's going on. So that's why I was able to complete it for me. Otherwise, I could have just typed all of this directly. So that's basically the structure of this class. Now, in addition to that, there's going to be, I want to create a constructor on this. So we'll say def init, all of those different things. And yep, that's exactly what I'm looking for. So ID, we're going to default to a new UUID. And so we'll do that here as a part of the code. Then street address, we're going to be able to bind straight in based on those values. So this is what I'm looking for. This will let me create one of these things by passing in values and make sure that the ID always is a random UUID before we save. So this now maps to the commercial property table. Now that I have this, I'm ready to start using the ORM. So this is all just to set up the ORM. I haven't used it yet. Now we're going to use that as a part of get all and save. Okay, so I'm going to rearrange these just because I like to alphabetize. So now that we've got this, what we're going to want to do is we're going to create a method that's going to create a session that we're going to use in both of these other two. So we'll say static method def create session. And that is what I'm looking for. So we're going to create a session object. I want to do little s. So we'll create a session object from session maker. We're going to bind to our engine that we had up here. So bind equals engine session maker. That'll give us a session maker. And I'm going to actually rename that. I don't think session makes sense. And then we'll return session maker to give us a session object. What is the type of that? Session. I'm not going to worry about the typing. So that's going to give us our session. Now that we have our session, what we're going to want to do is use that to save and retrieve. So let's start with the save, just because sequentially that's going to happen first. So on the save, what I need to do is first I need to convert the commercial property into a commercial property record. So let's do that. So we'll say record equals commercial property, and yep, that's exactly what I'm looking for. So we'll pass in street address, city, state abbreviation, and postal code. I can just use the positionals. I don't need to do the named arguments. And that'll shorten this up a little bit. So I'll just one-line it. So create a commercial property record from those different values. Next, we need to create our session. Again, it's going to help us out. We're going to add to the session our record. Then, once that's all done, we're going to commit. And it does want to close, so we'll go ahead and close that. So we'll open our session, commit the record, and then close the session when it's done. So this is a save. It's going to add to the database. Now in the retrieve, we need to get these records back out. So again, we are going to need a session. And then this is exactly right. So here's our records. So records equals session.query. We're querying over the type commercial property record. That is the class that we created that maps to the table. And then we say, give us all. Now you could filter that down. You can select just the top 10, or you can filter where, all sorts of things you can do there, but that'll give us our records. Now that we have the records, we need to convert these into commercial properties because these are commercial property record objects. So we'll, close is fine. So we will return. All right, so it's going to help us with list interpretation or list. Oh gosh, I forgot the name. But basically, we can run through the list and it'll figure out what we're trying to do. So this is pretty close to what we want. I'll go ahead and do this, and we'll take a look and see what we're doing here. So this syntax, what we're doing is we're creating a list, and we're creating a list from another list. So we're saying from the records list. So that's the in records. We're going to say for each record. What are we going to do for each record? We're going to take the record and create a commercial property from that record. So we're going to pull the values out and create a commercial property. So you read this syntax in reverse. So you say, basically from the records, in records, for each record, do this. So that's basically the syntax here. That'll do the conversion. That all looks right. Let's run our test and see if we have a pass. So commercial, run. We do. So we've got the SQLAlchemy up and running. It's inserting into the database. It's querying that once it's done and making sure it's there. You're welcome to open up SQL Workbench or MySQL Workbench and connect directly if you want to verify for yourself. But it is actually doing a full round trip, saving the record to the database and then retrieving it back out. So that's the SQLAlchemy, the ORM example. For residential property, we're going to switch gears. I'm going to use a command query style package. For this one, we're already using one as a part of the schema. We're using MySQL.connector. I'm going to use the same thing. So I'm just going to import this at the top of the file. So that'll be our connect. And again, I'm just going to alphabetize. And we're going to want a static method that will be create connection. And we're going to return connect host. This is localhost. Port 3306. User is root. Password is, again, whatever you had as a part of your password. Database is real estate. So here's our connection. We're going to use this. And again, all this information just comes from the schema file. All this information's here. I'm just basically pulling it over into a new function. Now we're going to use this to connect to the database. Again, we'll start with the insert. So to do an insert, we're going to need to start with a connection. Now, connection is auto-closable, which means, well, not auto-closable, that's Java, but it is, it can use a context, so I can use with. So I'll say with that, also with connection.cursor is cursor. Now I'm going to execute my insert statement. And again, it's going to help me out with some of the syntax. So we want to say cursor.execute, insert into residential property. Here's the column names. The values are going to be random UUID and then 4 different string parameters, %s, %s. So this is how we do it in Python. And then we're going to create a tuple that is the values that we're going to bind to those s's. Once we're done with that, we'll just say connection.commit to make sure it saves it to the database. So there's our insert. Our retrieval is going to be the opposite. So we'll still say with residential property connection. Okay, it's going to help me out. We'll see what it does. With connection cursor as cursor. We will select, I'm just going to do a select star, so I don't need to specify. You can certainly specify the columns. I'm going to do everything. We're going to fetch all, and then again, it's going to do string or list. Man, it starts with an I. I cannot remember the name of it. But it's going to basically interpolate or read through the list and understand the list. So from the rows, for each row, we're going to create a residential property, and we're going to grab row 0, row 1, row 2, row 3 to get those values out. Now, star means it's going to be from the different, it's going to be everything. So ID is in there. So since that, I need to change these by 1 because ID is the first column. So I'm going to ignore 0, which is ID, and instead I'm going to get everything else. Now, this will be in the same order that the columns are listed in the database. Street address, city, state abbreviation, and postal code. So the order matters. If you needed to change the order, that's why you might want to specify the exact column names here. So you can say street address, city, state abbreviation, etc. And now we can change these back to 0, 1, 2, and 3. But again, I'm just going to do star just to make it simple. That means that I need to skip the ID column, so I start at 1 instead of starting at 0. That's basically the structure. Let's go and run this and see if this works. We have a passing test. Looking good so far. So let's run everything one more time, make sure, and we have failures. What's happening? So what's happening is the database is continuing to accrue records, and it's not deleting anything. So we're adding more and more every time we run this test. So there's a few different ways to handle this. What I'm going to do is inside the test itself, I'm going to basically just reset the data. So we'll say reset data. We'll do this on each of these test methods. Now I could do anything I want in terms of how I reset. I'm just going to use the MySQL connector again. So we'll create a def reset data connection. So let's just copy our connection here. Here we go. With cursor, delete from. Okay, it's helping me out. Excellent. So we'll delete from commercial property. We'll delete from residential property. I don't believe MySQL supports truncate, so you'll have to do a delete instead of a truncate. And then finally, we will commit when we're done. This should reset the data. Let's run the test again and see. There we go. We passed. Let's run it one more time just to make sure we still pass. So that is basically the conclusion. Let me walk through this one more time just to make sure we can see all the different pieces because there was a lot happening here. So starting off, the schema file, we need to change the password and then run this locally, run this file locally for schema to create the databases on your local. Once that's done, we're ready to go into the properties and start implementing. Starting with SQLAlchemy, we had to run these boilerplate methods here, or calls. So basically we have our connection string. A lot of this you can do internet searches on to figure out. The root is the username from the schema file. The password is obviously your password. Localhost is instead of 127.0.0.1, those are the same thing. 3306 is the port, and then the database name. We have to create the declarative base, and then we have to create all for metadata. Then we create a class for the commercial property record. This maps to the commercial property table. Here's our column specifications, and then a helper constructor just to make things simpler for us. From there, we're able to do the actual implementation. So we create a method to create a session for the ORM SQLAlchemy session. Get all is going to be from that session. We're going to query over commercial property record, get all, and then do basically project the list out into a different list. We'll go from commercial property records to commercial property objects. Save the other way around. We'll create a record from our commercial property. We'll add it, commit it, and then close the session. That's the SQLAlchemy side. On the MySQL connector side, we just simply did our import, single import here. And then in the residential property, we created a method to create the connection. Again, these values coming straight from the schema file. Then we have get all, so we're going to create a connection, open a cursor, we'll execute the command, fetch all from the cursor, and then project those out into residential property objects. And then on the saves, just going backwards. So we'll create the connection, create the cursor, execute an insert statement, bind the values to that command from the %s, and then commit that back out. Finally, in the test, just to make sure that we reset the database each time, I just call a simple method reset data, which connects to the database, runs our delete commands, and then commits on the connection to make sure we commit those deletions. Whew, that was a lot. I hope that's helpful. Please try to experiment some more with different libraries, different packages as you get a chance. The more you learn, the more confident you're going to be and the more equipped you're going to be for new projects down the line.